Okay, kia ora everyone. So my name's Zoe. As Doug mentioned, I'm going to talk a bit about the dispersal side of our project. So really trying to understand how much of a role dispersal plays in the reintroductions on the mainland in particular. So beyond islands, as you probably are well aware, we've been pretty good at doing reintroductions and translocations on islands in the past. We're pretty good at getting an island, dropping some baits and getting rid of everything, which means we can put birds back and they've got nowhere to go. So they generally do pretty well and we can have quite good success there. But as we're getting more islands filled up and we're running out of places, we're kind of getting a lot more reintroductions across mainland New Zealand. And part of this is in response to some programs like Predator Free 2050, where we're getting a lot more habitat becoming available thanks to great predator control and restoration attempts. But the problem with this is that mainland areas are quite hard to manage. You know, large areas, New Zealand's a pretty complex topography. We have amazing hills and ruggedness that is quite hard to manage. And also on the mainland, we have a much greater chance of dispersal. We don't have the opportunity to eradicate as often and species can go wherever they want. So dispersal actually becomes a bit of a problem. And as John mentioned yesterday, you know, a lot of people think of connectivity and dispersal as a good thing, but in the case of reintroductions, it can actually not be great and turn out failed reintroductions. So we really want to kind of look at how this dispersal is impacting what we do in mainland landscapes. So an example of how dispersal might influence a reintroduction, we've got an example site here of the Hunua Ranges, which is sort of a 600 hectare managed area inside a highly connected landscape. The entire reserve, managed reserve, is surrounded by forest. So you can have a little site in the middle here, which is surrounded by a sort of unmanaged matrix where we get our predators and threats. So we want to keep species in that reserved area. So we might do a release once we get our reserve and management down to those sort of potential predator thresholds that Doug was talking about. Once we think they might be there, we can release birds and hope they do okay. And once we release them, we have this dispersal element that might influence how well they do. And there's various different stages to this. So first we might get a post-release dispersal. So this is when we release the birds and then they have a bit of an explore. They're in a completely new environment. They don't know where they are. They're trying to find new territories and trying to pair up. And so they might disperse around and we might get a few individuals during this process move outside, especially in these highly connected landscapes. And once that happens, if they leave outside of our reserve, we're going to lose those individuals from the population. So that's that first stage where dispersal might have a huge impact on your establishment of a population. If we get some individuals survive this first initial stage, we might get them doing their general home range movements and foraging and territory dispersal. And this could, again, be inside the managed area, which is great. They're going to be protected. But if they move outside of this area, we're going to lose those individuals from the population again. So it's another stage where dispersal is going to influence our survival of individuals that we've released and therefore our reproductive output there. And finally, if they survive all of this and they find a pair and they think they're doing okay, we might get some juveniles show up in a population. But then juveniles undertake a natal dispersal. So during this time, they leave their parent home range and try and find their own territories and partners. And again, this could take them outside of our protected area. And again, once they leave our area, we're going to lose those individuals. And so we might think that we've got a huge area where we can have lots of individuals, but if they're leaving our protected area, we're not going to have a very successful reintroduction. And that was the case with Hunua and robins. Totowai, they didn't do so great. There's a few individuals still there, but we haven't had as much success there. And we think that might be because of these dispersal aspects. So we wanted to kind of actually monitor this dispersal and see what's happening. So we've been working at a couple of sites, and one of these is Turitea Reserve. So this is an example of one of these large connected landscapes. It's about a 2,000 hectare reserve just outside of Palmerston North. And you can see this predator control network across the reserve. So it's quite intensely managed for such a large area. We've got bait stations and predator traps, and the traps are checked at least once a month, so it's quite intensive. And it's a highly connected landscape, so it's connected to the Tararua Ranges to the south. So if we reintroduce birds, particularly mobile species, they could fly as far south as they want, which we don't really want to. But one advantage Turitea has is it does have some forest boundaries which to the north, which would hopefully reduce the chance of dispersal. So we conducted a robin translocation to Turitea Reserve last year, and we released them at the start. And so this is a site where we've been monitoring and tracking birds. But we get to this complication of large landscapes and very small birds in very tough terrain. And how do we actually monitor these large landscapes? Our first kind of question to this is, can we actually do it? We're talking about much larger areas than we've been used to in the past to track these very small species. And so we wanted to test a few ways in which we could do this. So one of these is we've been working with Chris Muller, who's a PhD student at Massey University, and using a drone and receiver system that he's developed during his thesis to help track transmitters from the air. So it means that we don't have to run around in the bush quite as much as we would normally do. So we can fly grid lines across the habitat, and we can detect these tiny transmitters with fairly good accuracy. For the Totowai transmitters, we can get to about 50 meters accuracy, which for a 2,000 hectare area, when you're looking for that small bird, is quite handy. So this, in combination with ground surveys, was kind of our approach to try and track Totowai over such a large area. So following our Totowai reintroduction, we monitored them for about 11 weeks, which was about the battery life of the transmitters, and we did a combination of aerial and ground tracking, and we wanted to see kind of how that combined approach would work if we could actually track these birds. And in total, over those 11 weeks, we did about 300 hours of ground surveying, which covered almost all of the reserve, and aerial surveys, which was about 10 hours of flight time, and that covered about 600 hectares of the reserve. And over those 11 weeks, we actually managed to track quite a few of the birds, which was quite surprising and heartening. We got about 300 locations recorded over that time, and almost all of the birds were found at least once during the 11 weeks monitoring, which is great. The last bird was actually discovered during the breeding season, so we did actually get records for every single bird we released. And most of those we did find in the reserve, so it was great. And we managed to monitor, so it was actually really encouraging that we could monitor a large area. And it was really to do with this combination of aerial and ground tracking. And as much as aerial seems to be, the use of drones is kind of in wildlife management is quite exciting, and people get excited about it, and it could have great applications, but on its own, it's not necessarily going to replace those hours and hours of trudging through the bush. It was really great, particularly when we started to get birds settling and we could check areas that we vaguely knew birds were. We could fly over that area quickly, but we still needed that ground truthing to look for more blind spots, try and find those first locations of birds. So there are some limitations to that, but we were really encouraged with the fact that we could actually track birds. And while we were doing this, we had the opportunity to look at how birds responded to the drone monitoring. So there's a bit of concern about how wildlife respond to having drones in their environment. And there's not a lot of information about forest birds in particular. Most of the research on drones and wildlife has been more on wetland species or in open habitat species. So while we did our aerial monitoring, we took about 2,000 observations of all the species in our sites, which was about 31 species. And it was great. There's only 8 of them actually showed any direct response to the drone. Most of the species were totally oblivious to a drone flying 10 meters above them. In some cases, we had kiddo performing display flights while the drone was directly overhead, so they were kind of totally doing their normal thing. And most of the birds that did respond to the drone were our water birds, so the birds that were sitting on the dams, so our ducks and shags, and they would respond very similar to how they would if a human approached them naturally anyway. So that was great. Even in some cases, we had scenarios where we had the drone fly over tortoise nests and the adults continued to feed their chicks. They continued to sing normally while their drone was directly above them. So that was a good sign that if you are interested in using drones for wildlife management, particularly in these forest settings, that most of our New Zealand forest species don't seem to be too fussed by them. So that was great. And we've got that coming out in Natunas later this month, I think. So once we could figure out that we could actually track them, we wanted to know where they were going. And as I'm sure you're aware, most robins like to go through Supplejack, which is great fun. So where did they go? So we're back to Turitea, and our star is our release site here. We chose this release site because it was kind of central in the main lowland forest area that we knew would be good habitat, and we hoped that the dams would kind of help guide them and that the forest edges would also minimize their spread. What we found over the 11 weeks, so this is all the locations showing up, yep. So this is the spread of birds that we found across the site. As you can see, they kind of were very much in that northern area. There's a bit of a natural barrier with the elevation and the habitat of the vegetation change to the south, which is again something that we had hoped would kind of stop them dispersing too far and would keep them in the core area, which it seemed to do, which was fantastic. So we found all of the 40 birds in this area. And this post-release dispersal range ended up being about 800 hectares in size. So if you think about a site like Hanua's, which was only 600 hectares, you can totally see why that dispersal might have been an issue there, because if we know that birds are quite capable of dispersing 800 hectares in that initial weeks after release, they're totally going to be leaving a smaller site. One interesting thing about this is if we compare, we did our 11 weeks of monitoring. We left them for a few months after the transmitters died and then came back in the breeding season a few months later, and we started monitoring them again. And most post-release monitoring for species, especially in these larger sites, because it's hard to track them, has relied on breeding monitoring. So you go back a few months later and then you start seeing them. And if you look at the sort of area that the established territories were covering, that area was only covering about 200 hectares. So the sort of extra information that we gained from doing all that intensive monitoring 4-time-fold increased the amount of area that we know that they were covering in the reserve. So again, these sort of large areas are quite necessary to, large protected areas are kind of necessary to protect the dispersal. And if you look at only a breeding range or where the territories are, you might not be getting the whole picture. An interesting part to note on this was that at the end of the 11 weeks monitoring, I knew roughly that half of the birds had settled, so we knew exactly where 20 birds were after the release. Sorry, 40 birds had been released at the time. And so we knew the location of 20 birds, and there was another 10 birds that we knew were still in the reserve, but they were kind of moving around. And then there was a few birds that we weren't 100% sure where they were. So I was quite confident at the end of the monitoring that most of the birds had remained in the reserve, which was really great news. So another site that we have been working at that we really wanted to use as a site to look at dispersal was Taranaki Maunga, and here we were working with the TMP and DOT guys there in their A24 block, which is again another quite large 1,000 hectare managed reserve within this matrix of a highly connected forest landscape. And at this site, 100 totoi have been released in 2017. And one of the questions that we wanted to look at was, was this site large enough to actually cover that dispersal that we might expect? And also we wanted to look at natal dispersal at this site, which is something that we don't know a lot about. So natal dispersal, so that's when the juveniles are leaving their home range and trying to find their own place. We know that juveniles can disperse quite far at Taranaki. They've been picked up over 10 kilometres away at Lake Mangamahui. So, they have the opportunity to disperse. So we were really curious to know how many of the juveniles might be staying in the management area, and if there was any alterations to the management block that might actually help capture any dispersal that they might be missing. As you can see from the 2020 breeding monitoring, that the locations of totoi in the reserve, it's got this very distinctive pattern that they kind of are not going higher up the mountain, and they're kind of following down a stream down here. So this is where all our territories and observations are. And we wanted to try and see where the juveniles were going in this block. So one thing we quickly learned about Taranaki, it's a pain in the ass site to manage. All those rangers out at Taranaki can be given a pat on the back for the site. Over the course of a few months while we were there, we only managed to get 8 juveniles due to weather and missing birds and COVID and all the fun stuff that goes with fieldwork. We managed to track 8 juveniles with transmitters, and we banded another 11 birds. So we tracked juveniles again over sort of a 3-month period, and of the 8 tracked birds, we actually only found 2 of those in the reserve in that time. Another 2 banded birds were picked up during the monitoring, one inside the reserve, in the management block, and one outside of the management block. So it was pretty hard to track juveniles, but we did get a little bit of information, and possibly a lot of those juveniles are leaving. But we are still seeing recruitment at the Taranaki site, so there is that little bit of recruitment that's happening. So the site itself might still be large enough to capture enough of the dispersal anyway to have a population growing, although it's still early days for this site. Some interesting things that seem to be coming out of Taranaki is that there's this very clear elevational barrier. Birds don't seem to be going further than 600 metres up, and so, in terms of what we can learn for management, adapting the sort of shape and size of your area could possibly, if you were only looking at totoi, you could move some of the trapping efforts to lower areas to try and capture that sideways spread that seems to be happening. Yeah, so natal dispersal, it's a bit hard to figure that one out. But some of the take-home messages from what we've been doing, smaller sites like Hanuas, which smaller sites in inverted commas, at 600 hectares are possibly not large enough to capture the dispersal that's happening, particularly the post-release dispersal and that natal dispersal that we know might be quite large. Also, if you think about sort of edge effects at these sites, we know that there can be quite significant edge effects in some of these sites where our predator control is not as effective on the edges. So even a 600 hectare site, if you take that into account, your core area that's protecting individuals might not be as big. And so for species that are even more sensitive to predators such as tieke, that are sensitive year-round rather than totoi, which are mostly sensitive during the breeding season, you're going to see this rapid decline much quicker if you're not capturing that dispersal. Larger sites, like our 1,000 hectares and 2,000 hectare sites, might be large enough, but those have increased management challenges, trying to make sure that your predator control is effective across that entire area to the level that is getting those predators to that threshold we need. That's much more complicated. And monitoring is... Sorry. Yep, I'm almost done. And monitoring is quite difficult. So, a combination of the aerial and ground serving really helped us. So for reintroductions, you really need to kind of consider all these dispersal stages. And natal dispersal is still a bit of a mystery, but we're hoping that all our banded birds, and we've been banding more as we go, will give us a bit more information about how far they're going. Yeah, and so what's next for us? We've got a little bit of habitat modelling going on. So now that we know where the birds ended up and where they moved through, we want to look at what exactly the landscape features and the predator control features that might have influenced how they were moving. And again, to try and create an entire population dispersal model where we can include that post-release data, the home range data, and also the natal dispersal if we get enough of it, to try and predict how big your population will disperse, and therefore what sort of management areas you're actually going to be needing to have to capture that entire population. And we've got some breeding success monitoring happening with a master student, which Doug is going to talk about a bit more, so I'll let him take over from here. Yeah, thank you. Yeah, and thanks to everyone who's helped on this project.
Awesome. Yeah, it's super interesting, Zoe. That's an amazing amount of work.